Now moving on to part 2, conditions for natural selection. Now let's focus in on natural selection specifically and the conditions necessary for it to occur. Natural selection is founded on 3 principles. The first being that most qualities are inherited or inheritance. More offspring are born than can survive, competition. An offspring with more desirable characteristics will survive and produce more offspring, variation. Natural selection can only take place if there is variation or differences among individuals in a population. Importantly, these differences must have some genetic basis, genetic variation. Otherwise, the selection will not lead to change in the next generation, right? This is critical because non-genetic reasons can cause variation among individuals, such as an individual's height because of better nutrition rather than about different genes. But you can't pass on better nutrition to the next generation. Make sense? Let's look through 4 scenarios together, and while I read out each scenario, I want you to try to determine whether evolution by natural selection would occur in each scenario. Consider the presence or absence of the 3 key components, inheritance, competition, and variation, as we work through each example. Starting with scenario number 1, chickadees. A population of birds, chickadees, live on an island with abundant food resources. The birds vary in beak size, with some having long beaks and others having short beaks. The long-beaked birds can reach deeper into flowers to access nectar, while the short-beaked birds can easily crack open seeds. Over time, the birds with longer beaks are more successful in obtaining nectar, while the birds with shorter beaks are better at cracking open seeds. Would you expect evolution by natural selection to occur in this scenario? Yes. The variation in beak size provides an advantage to different individuals depending on the available food resources. The long-beaked birds have a higher chance of survival and reproduction due to their ability to access nectar, while the short-beaked birds have an advantage in cracking seeds. This selective pressure leads to differential survival and reproduction, favoring the traits that confer better fitness in each food niche. Over generations, the frequency of long-beaked birds and short-beaked birds may change as a result of natural selection. In essence, it will favor either beak size over a mid-sized beak size. Scenario 2, rabbit paradise. A population of rabbits lives in an environment where there are no predators, and the food supply is constant and abundant. The rabbits do not exhibit any significant variation in fur color, body size, or other traits. They're all pretty homogeneous. Would we expect evolution by natural selection to take place in this scenario? As it turns out, evolution by natural selection is less likely to occur in this scenario. This is because natural selection relies on differential survival and reproduction based on heritable traits that provide advantages in a particular environment. In the absence of selective pressures, such as predation or limited resources, there would be no significant advantage or disadvantage associated with a particular trait, right? We're lacking that component of competition. Without such pressures, the population is expected to remain relatively stable in terms of genetic makeup. Also, there's not too much to choose from in this population, as all the rabbits are pretty darn similar. There actually is an island in Japan, if you're curious, nearly free of rabbit predators. However, the rabbits on this Japanese island still undergo natural selection because they exhibit different phenotypes and must compete with each other for food and available resources. So those more capable of surviving the landscape of this real island and outcompete the other rabbits for available food will survive and pass down their beneficial traits to that next generation. Alright, scenario 3, antibiotic-resistant bacteria. A population of bacteria is exposed to an antibiotic that kills most of the bacteria, but a few individuals possess a mutation that provides resistance to that antibiotic. These resistant bacteria survive and reproduce, passing on their resistance to future generations. Would we expect natural selection to occur in this scenario? Yes, evolution by natural selection is occurring in this scenario. The antibiotic acts as a selective pressure, favoring the survival and reproduction of bacteria with the mutation that provides resistance. The non-resistant bacteria are eliminated by the antibiotic, while the resistant bacteria have a higher chance of survival. As a result, the frequency of the resistant allele increases in subsequent generations, leading to the evolution of a population that is more resistant to the antibiotic. This process is an example of directional selection, where the environment favors individual with a specific trait. And we're going to touch on this more later in this lesson. But for now, we're going to move on to scenario 4, polluted lake fish. A population of fish lives in a lake with plenty of food resources, but the lake begins to experience increased water pollution due to human activities. The pollution affects the fish by reducing their reproductive success and causing a decline in overall population size. Would we expect evolution by natural selection to occur in this scenario? Probably. Evolution by natural selection may occur in this scenario. The pollution acts as a selective pressure that affects the reproductive success of the fish. If there is variation in the population regarding their tolerance or sensitivity to the pollution, individuals with higher tolerance are more likely to survive and reproduce, passing on their genes to the next generation. Over time, the population may evolve increased tolerance to the pollution, improving their chances of survival and successful reproduction in the polluted environment. This scenario demonstrates the potential for natural selection to drive adaptive changes in response to environmental pressures. So, in summary, natural selection occurs when there is heritable variation, meaning that traits can be passed on from one generation to the next. Additionally, individuals with certain traits must experience differential survival and reproduction, meaning that some traits provide advantages for survival and reproductive success. Alright, so moving on to part 3, types of selection.